Hey guys, so here's the notes for 5.8 day 2. Now here, you will need a graphing calculator to do this section. So either you have your own graphing calculator or you will need to download the TI-84 app, okay? If you have not already done so, I'm going to show you where you can find it so you can download it. Okay, so if you go into, scroll down, into our online learning info, okay? Then you're going to go to additional math resources here. Now you're going to scroll down and you're going to see the free TI-84 graphing calculator app for Chromebook. You're going to click on that. And then for me, it's not compatible, but yours will be fine. All you have to do is download it, okay? Now there is another way you can get here. Remember, you can always click on the Need Help button. That will take you to here, and we can go to the additional math resources and go to that same spot, okay? So make sure if you don't have a graphing calculator, you need to come here and download this app to do the following, okay? Okay, let's go ahead and get back into the notes here. So we are doing 5.8 day 2. We are using the graphing calculator to find local minimums and maximums as well as x-intercepts, okay? Now let's talk about some vocabulary here. First, turning points. Turning points are going to be your local minimums and maximums. So they correspond with the local min and max values, okay? Every time the graph changes direction. So when we talk about changing direction, that means we are either going from increasing to decreasing or vice versa. Okay. Now, one thing you should know about turning points is we can figure out how many there are just knowing the degree. So remember, N represents the degree. So that means there is at most N-1 turning points. So you basically take your degree of the function, and of course, remember your function can either be in standard or in factored form. You'll take that degree, subtract from 1, and that's at most how many turning points or how many local mins and max you can have total, okay? Now let's talk about a local max. So that local maximum is going to be the y-coordinate of a turning point if the point is higher than all nearby points. Basically, it's going to be the point that's going to be at the top of the hill, okay? So any point that's at the top of the hill or at the top of our little turning point or of our bump, that's going to be a local max. On the opposite side, local min, the y-coordinate of a turning point if the point is lower than all nearby points. So basically this means that if we have a hump going like this, then basically the bottom of it, that's going to be our local min, okay? So remember, turning point, that is when we either go from increasing or decreasing or vice versa, decreasing to increasing. And then that local min and max, those are going to be those highest or lowest points there. Now I also have another little thing that we can use here. So notice I have this graph of this blue one, okay? Notice that we have 2 turning points, okay? So I'm going to write that down. There are 2 turning points. So remember, turning points include both mins and maximums. There is 1 local max and 1 local min. And there can be more than 1. And you're going to see that in our notes as well as the homework assignment, okay? So notice the local max is going to be the point that is at the top of our hill. Notice this graph, reading it left to right, goes from increasing to decreasing. So this is our turning point, and it's a local max because it's at the top of our hump here or at the top of the hill. Then we change from decreasing to increasing. So at the bottom here is another turning point, and this is actually our local min because it's at the bottom of the hump or at the hill. Okay? Okay, make sure you watch the next part. We are now going to use the graphing calculator to find minimum, maximums, and x-intercepts.